Hey, let's take a look at scale factor here. In this exercise here, we're going to be calculating scale factor from a figure and its image under a dilation. So I've added these arrows in here to show you that this is the original image, or the pre-image, I should say, actually, and this is its image under the dilation. So in all cases, follow the arrows. The scale factor is the number that each of these sides were multiplied by in order to get the sides on the other figure. In this case, you look 6, 6, 12, 12. It looks like each of these sides was multiplied by 2, so scale factor is 2. But I'm going to show you how to calculate that, in case it's not such a simple problem. In general, scale factor, and you want to make a note of this, at the top of your sheet perhaps, scale factor is after divided by before. Now, this is not a real technical, mathematically formula sort of thing, but this sort of idea can be used in lots of different situations. So scale factor is whatever the size was after the dilation divided by whatever the size was before the dilation. So in this case, 12 is the after, 6 is the before, so 12 divided by 6 equals 2. One thing you do want to make sure of is that you're dividing the correct side by the correct side length. I couldn't just go 12 divided by 5. That really wouldn't work. But I think it's fairly clear here that the 12 corresponds to this 6, and this 12 corresponds to this 6 over here. Okay. So in this case, by the way, since our scale factor was greater than 1, then this is an enlargement. So you need to tell whether it's a reduction or an enlargement. Basically, are you making it bigger or are you making it smaller? If your scale factor is bigger than 1, you're making it bigger. So let's make a note of that. Scale factor greater than 1 is an enlargement, whereas scale factor between 0, scale factor is greater than 0 and less than 1. Gives us a reduction. So if the scale factor is bigger than 0 but less than 1. If the scale factor is 1, you haven't changed anything. You've just multiplied all the side lengths by 1 and it stays the same. If the scale factor is less than 0, then you're doing a little bit more than just enlarging or reducing. So we're not really dealing with that right now. But again, if the scale factor is bigger than 1, it's an enlargement. Less than 1, between 0 and 1, a reduction. Let's actually look at a reduction here before we move on. For example, here, our after 12 and our before is 20. You can see here this 20 corresponds to this 12. This 30 would correspond to this side. We could figure out what that was if we wanted to. Okay, so after is 12 divided by before, which is 20. Let's see, we could reduce this. Let's see, divide them both by 2, that's 6 over 10. Divide them both by 2 again, that's 3 over 5. We could turn this into a decimal if we wanted to. That'd be 0.6. And we can see that 3/5 or 0.6, at this point I can tell, well, it's somewhere between 0 and 1. So this is a reduction. So anyways, go about the rest of these. You've got front, and you got just a few in the back there. Again, you want to figure out what the scale factor is. In every case, it's after divided by before. And you could turn it into a decimal if it's appropriate. Now, if your decimal turns out to be a repeating decimal, you have to leave it as a fraction. If you write down, if this were 0.666666666 and you just wrote 0.6, you'd be wrong. 0.666666666 is 2/3. Leave it as 2/3. If you have any questions about it, just go ahead and leave it as a fraction. Just make sure you reduce the fraction, that's all. All right. So make sure you check your answers before you're done, and good luck.